going to cover another topic, isomers. Isomers are compounds which have same molecular formula but different structural formula. Just to give an example, from alkane family, we will pick up C4H10. C4H10. This is the molecular formula. Now this formula can be represented in two different structure formulas. Let's see how we do it. Number one, C in a straight chain, CH3, CH2, CH2. You might ask me a question, how come I'm putting 3H over here and 2H over here? Carbon, the atomic number of carbon is 6 and it has 1s2, 2s2, 2p2. So there are 4 electrons in the valence shell. So that means carbon can form 4 covalent bonds. It can form 4 covalent bonds. So it has 4 valencies. 4 valencies. So that's why carbon is, one valency is occupied with this carbon and 3 rest of the valencies are occupied with 3 hydrogens. Similarly here, this carbon is attached with these 2 carbons, 2 valencies, and 2 hydrogen, the rest of 2 valencies. Similarly for others. Anyway, so C4H10 we can write in a straight chain and we can also write them in this form. CH3, CH, CH3, CH3. So just check if we have 4 carbon and 10 hydrogens. 1, 2, 3, 4 carbons, 3 to 5, 5 to 7 and 3, 10. So 10. Here also 1, 2, 3, 4 carbons, 3 hydrogen 6, 6 and 3, 9 and 1, 10. So you see that both have same molecular formula but different structure formula. That's why they are called isomers of each other. They are isomers. They are isomers. So isomers can form in a different ways, having same molecular formula, but structure can form in a couple of different ways. So we'll see what are those ways. First of all is different shapes of carbon chain. I just give you an example of C4H10. Let me give you another example. Let's take the C5 and H12. So there are 5 carbon and 12 hydrogen. Let's see. The first one would be CH3, CH2, 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 CH3. So 1, 2, 3, 4, 5 carbons, 3 to 5, 5, 4, 9 and 3, 12 hydrogen. So this is straight chain. This is a straight chain. Another example could be CH3, CH and CH3, CH2 and CH3. In this also 1, 2, 3, 4, 5 carbon, but 3, 3, 6, 6 and 3, 9 and 3, 12 hydrogens. But here this group, methyl group, is become a branch to to this main chain. So we can write this another way also. Carbon and 4 methyl groups we can connect surrounding the central carbon. So you can see 1, 2, 3, 4, 5. 5 carbons, 3, 3, 6, 3, 9, 3, 12 hydrogens. So all 3 of them are isomers, and they are isomers because of the different shape of carbon chain. Carbon chain has different shapes. So we have another way we can isomers can form, and that is functional groups at different positions in carbon chain. For example, let's have C4H8. This is the molecular formula of butene. We'll talk about how to name these chains later, but right now I'm trying to explain the isomers. So I can write this as C H2 double bond C H CH2 and CH3. So you can see that double bond is at this position. We have 1, 2, 3, 4 carbons, 2 and 3 hydrogen, 3 and 2, 3 and 3, 6 and 2, 8 hydrogen. I can write the same formula in a different structure also. CH3 C H double bond CH CH3. So now the double bond has come to the middle position. The position has changed, but they have the same molecular formula. 1, 2, 3, 4 carbon, 3 and 3, 6 and 2, 8 hydrogen. Somebody might think we can write another structure also. Let's see. CH3 CH2 CH double bond CH2. But this one and this, they are same, because if you will name it, you will start naming from the left hand side. So it is at position number 1. Here double bond is on the right hand side, so I will name the chain from the right hand side. So it's still on the position number 1. So this and this, they are actually same structure, they are not different. That's why we have 2 isomers for butene, because of double bond is at different positions. So isomer can form another way also. Different functional groups. Just take an example, C4H8O2. I can write down this as CH3 CH2 CH2 COOH. So this is a carboxylic acid. So you can see 1, 2, 3, 4 carbons, 3 to 5 to 7 and 1, 8 hydrogen and 2 oxygens. I can write down the same formula in a different structure also. CH3 CH2 COOCH3. So you can see 1, 2, 3, 4 carbons, 3 to 5 and 3, 8 hydrogen and 2 oxygen. But this is ester. This is ester. This is ester, but this one is carboxylic acid because of this, and this one is because of this. So you can see different from the same molecular formula we can have different functional group also, and they are also isomers because they have different structure due to different functional groups, but they have same molecular formula. One important thing I forgot to tell you is that they can have similar chemical properties, but different physical properties, except the last type. Why? Here the functional groups are itself different. So we know that by the definition of functional group, it's a group of atoms having similar or same chemical properties. So definitely if this is a different functional group, it should have a different chemical properties. But in the first two cases, functional group remain the same. Only the position of functional group, beg your pardon, the position of functional groups might change in the carbon chain, or carbon chain can be straight or branched. But however, in both the cases, functional group remain the same. So in these two cases, similar chemical properties, but they will have different physical properties. But the last case, it will also have different chemical properties.